leaning against the building, which is steeper? So we got ladder A in red and ladder B in blue leaning up against that building. Which one is steeper? Which one's more difficult to climb? B is steeper, right? We can intuitively tell that that's going to be the steeper one. But we come up with a very specific mathematical way of determining that. So we compare the vertical distance from the base of the building and the ladder's building to the ladder's top with the horizontal distance from the ladder's foot to the building. So we figure out the vertical distance, which we can see from the grid it is 8 feet, and then we figure out the distance on the base from the base of the ladder to the wall for each of them. And we see for the blue one it's 2 feet, and for the red one is 4 feet. And then what we do is we do a ratio of the two. So ratio of vertical distance or horizontal distance. So if we do that for each of them, what is the answer for ladder A? Ladder A, the ratio would be, so vertical to the horizontal, 8 over 4, which is equal to 2. And for ladder B, it would be still 8, right? Because it has the same vertical distance divided by 2, giving us 4. And so those are the two different results we would get. Okay. The ladder B, as we intuitively saw, is the steeper one, and it also, this ratio gives you a bigger value. So it kind of confirms that when we have bigger results from this ratio, that means that that we get steeper lines or steeper ladder in this case. Any questions about that? No? Okay. So this is our definition to compare the steepness of two objects, such as two ramps or two roofs or two ski slopes. We compute the ratio of the vertical distance over the horizontal distance for each object. The object with the ratio with the largest ratio is the steeper object. Okay, so the larger answer to this ratio is going to result in the one that's steepest. Bigger numbers result in steeper values, right? The line or the ladder or whatever it is steeper when this ratio is bigger. Good? Good. Okay. Another example, road A climbs steadily for 135 feet over a horizontal distance of 3,900 feet. Road B climbs steadily for 120 feet over a horizontal distance of 3,175 feet. Which road is steeper? Okay, so again, we got to think about the rise over the run. Maybe kind of come up with this diagram. So road A climbs 135 feet steadily, so they're describing a line, over a horizontal distance of 3,900. And then road B has 120 feet climbed over a distance of 3,175. So in the previous case with the ladders, the numbers were really simple. You could just kind of do that in your head. And also, just based on the picture, we could tell what the answer was. But now it's a little bit more difficult, right? The bases and the horizontal and vertical distances are different for both of them. So we're going to have to rely on some calculations, right? Bust out our calculator, figure out that ratio. It's the vertical divided by the horizontal always. And we figure out the result. So if we get our calculator, we see that this is what we get. It's going to be 135 divided by 3,900. We get 0.035. It's going to be 120 divided by 3,175. We get 0.038. And so which one is the steepest road? Road B, right? We get a slightly larger number. Larger numbers means it's steeper. So 0.038 is going to be a little bit steeper, a little bit larger than 0.035. So road B is just a little bit steeper than road A. Good? Any questions, comments, issues? Please resist the urge to want to put the largest number in the numerator. That just, it just seems like the answer would be prettier if we got a nice whole number or something. So People just like to divide 3175 by 120 because you know, they don't like decimals. So you get an ugly little decimal and they think they did something wrong. So it's not about that. You have to follow the order of vertical divided by horizontal. Now there's no like universal reason for why it's got to be that way. It's not like there's some sort of law in the universe that says it's got to be this way. Whatever, you know, we just needed to decide on something and be consistent about it. So, you know, we all just got together and decided, do it this way, and that's what all books do, and that's why we're all consistent across the board. So you just have to memorize it to do it this way. Vertical over horizontal, even though there's no real reason for why it's got to be that way. We just have to be consistent, all people working on this. Good? Good. Okay, so now, in a more general setting, if we're just working with some numbers on a grid, we would end up with something like this. So let's say that we have, let's draw the standard grid for it. We have the x-axis and the y-axis, and we want to draw a graph. So let's say we have that line right there. Okay, and let's leave this nice and arbitrary. So let's say that there's a point right in there, and there's some other random point right in there, and I want to leave them arbitrary. So I don't know if this is going to look good. So that's going to be some x value, and this is going to be some y value. So that means that this point is the point x comma y. Okay, so just arbitrary, we're just leaving it in general. It could be any numbers. Okay, x comma y. And then we have another point on the line. Well, I guess, should I call that x as well? Well, that's going to be kind of confusing because, you know, which one are you referring to? And then, you know, some books choose to come up with a new letter. Maybe that's A, this is x, that's A. But then it just doesn't look right. We're going to have to introduce a new letter there, and then up here we're going to have to introduce a new letter as well. And that just doesn't look good. So most books have decided to do the following. Put a little subscript in there. Right? So when the little numbers are on the right bottom part of the letter this way, it's the subscript, then that little number is just part of the title. It's part of the name of that variable. It doesn't mean to square it. It doesn't mean, it's not giving you instructions to do something with that letter. It's just part of the title, right? Like if you wanted to, if I wanted to name all my kids Eddie, Eddie 1, Eddie 2, Eddie 3, Eddie 4, otherwise they won't know who I'm yelling at, right? So subscript is just part of the title. It's part of the name. I could have just as easily come up with a new letter. It just looks messy to throw in a new letter, okay? And same thing with the y's. We're going to subscript them. So let's put y sub 2 there, y sub 1 there. And then that means that this is 1 there and 1 there. So we might as well call this point number 1. And then over here we got x sub 2 and y sub 2. So we might as well call this point number 2, even though that's kind of arbitrary. Okay, so now that we have those defined like that, then we want to think about this triangle that's formed underneath the line, this one right here. And we want to think about the distance from there to there and there to there. So this is the vertical change. This is the horizontal change. So let's think about this one first. How do we find this? For a minute, I know it's arbitrary and we're leaving it in general, but just for a minute, let's think about some numbers. If this was the number 5 on the number line, could this be the number 2? No, it would have to be bigger, right? So let's say it's the number 9. Okay, that makes sense. It's that way. So how do we find this distance right there? The answer is 4. Okay, but how did you get it? What's the equation that you would set up to get an answer of 4? This one minus that one, right? So it'd be 9 minus 5 would get you the distance between those two. Okay, but if we're leaving it in general, then this distance right there would be x sub 2 minus x sub 1. Good? Good? Same thing over here. Again, if we're just putting some numbers in there, like let's say that this is the number 7 and this is the number 11, then that would mean that this distance is 11 minus 7, or 4. And we would, just because we have some numbers, we instinctively put the biggest number first and then subtract the smallest one. As we'll see in a minute, it doesn't actually matter. So that means that this is 11 minus 7. So over here, leaving it in general with the variables, this distance right here is y sub 2 minus y sub 1. Good. The distance from there to there. And then the distance from there to there. Okay? And so now if we want to judge the steepness of this red line, we go back to our definition of the change in the vertical divided by the change in the horizontal. So we end up with this. So there's lots of different titles for this. We like to use, so we call it the slope. We also like to use the letter m. So either one of those is fine in linear equations. So m or slope. And in this case, it's going to be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Right, so that's the general formula. We also like to talk about rise and run. So this is also referred to as the vertical change. Vertical change. We also like to denote it as delta y. In math, this little triangle means change in. So change in y, that's another way to describe this thing. And then we also like to call it the rise. So all that language is referring to this. Talk about the rise, the change, the delta y, the vertical change. And in this direction, we like to call this the horizontal change. So horizontal change. We also use the notation of delta x, just like delta y, the change in x, the change in y. And then also we refer to this as the run. So in many cases, you'll see this written down as the rise over the run. I'll put it over here. We see that slope, which is also m, is also equal to the rise over the run. People talk about that all the time. And then finally, the slope, which is also m, is often seen as delta y over delta x. We don't use this notation so much right now. Down the road you might. We talk about this, or this verbiage we use a lot, the rise over the run. And then the more mathly definition is this one up here. Good? Good? Okay, so looking at the specific numbers that I wrote. Let me rewrite this over here. So if I just had, I had a 5 and a 9, and then I had a 7 and an 11, just to throw in some more specific numbers. So that would be a point there, and a point over there, and there's that line that connects it. Going that way, going that way. Okay, so I have the points 5, comma 7, and the point 9, comma 11. If I wanted to find the slope of this one using my formula, slope equals to m, which is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Right, there's my nice formula for the whole thing. When we are first introduced into an exercise like this, though, there's no particular reason for why this would be called point 1 and why that one would be called point 2. So somebody might make the decision of calling this one point 1, or someone might make the decision of calling this one point 2. And it turns out it doesn't really matter. So I'm going to do it both ways here so you can see that you end up getting the same answer. Okay, so first of all, the way I did it over on the previous board, let's call this point number 1, which means that this guy here is x sub 1 and this is y sub 1. And so if we call this one point number 2, then that means that this guy here is x sub 2 and this is y sub 2. And now when we plug them into our formula, it's going to be 11 minus 7, right? 11 minus 7 And then 9 minus 5. 9 minus 5. 9 minus 5. And so we end up getting 4 over 4, which is equal to 1. Good? Yes? Yes? Okay. Well, what if somebody had done it the other way around? They decide, you know what, I think I'm going to call this point number 1. So here, let me go ahead and I'll just squeeze it in here. If someone had called 5 and 9, 7 and 11. Okay, so someone comes in and says, I want to call this one point number 1. And I want to call this one point number 2. Right, so we have the point 5 comma 7 and the point 9 comma 11, which means that this guy is x sub 2 and this guy is y sub 2 and this guy is x sub 1 and this guy is y sub 1. Okay, so now we follow the formula. Slope is m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. X sub 1. So following the formula, we end up in the numerator with 7 minus 11. 7 minus 11. And in the denominator, we end up with 5 minus 9. So notice that in the numerator, we end up getting a negative 4, which is the opposite sign of that one. But in the denominator, we're going to end up doing the same thing. We end up with getting a negative 4, and so the whole thing still equals to 1. And so we still end up getting the same answer. It doesn't really matter which one is 0.1 and which one is 0.2, as long as you follow the rules. What's important is for you to be consistent about which one you've named 0.1 and which one you've named 0.2, so that if you've labeled here 0.2, and so you're starting in the numerator with the y with this, 7 minus the 11, then in the denominator you have to also start there with 5 minus the other one. You can't mix and match those and then you might get something wrong. Okay, so pick a point, the y1 goes, you start with that y1 in the numerator, and that same point you start with the x1 down in the denominator. So that's a common mistake. And the other one is, of course, to not forget to flip these around, right? So you can't have the other way around. Good? Questions, comments, issues? No? 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 Okay, so here's an example. Find the slope of the line that contains the points 1 comma 2 and 5 comma 9. So we have 1 comma 2 and 5 comma 4. So the first thing we have to do is assign them values of 0.1 and 0.2. Right? Got to label one of them as 0.1, label the other one as a 0.2. So, it doesn't really matter. Let's call this 0.1. Let's call this x1, y1. Which means that this one must be 0.2, which means we call that 0.2. Right? Point number 1, point number 2. Now we can plug it into our formula. The slope equals to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And so 4 minus 2 divided by 5 minus 1, which gives me 2 over 4, which is equal to 1/2. Any questions? No? 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 Okay? If you had labeled them the other way around, big or here, what would you have gotten? You would have gotten 2 minus 4 divided by 1 minus 5. Right? If you had labeled them the other way around, instead of starting with 4 minus 2, you had started here, 2 minus 4, and then 1 minus 5. Okay? And so you still would have ended up with the same answer. This would have been negative 2 over negative 4, which reduces to positive 1/2. Questions, 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 questions? No? Okay, so you get that. Okay, and then if we put it on a grid, we can see that we can also count squares. In some cases, as you'll see, they'll start off giving you the question by putting it on a grid. And if they're nice integer whole numbers like we have here, we could just count squares. So if we can see, we counted 4 squares going in the run, as the run, in the horizontal direction, and 2 squares going up in the rise, in the vertical direction. And so it's rise over run, 2 over 4 is our slope. Right? So in some cases, you can just count squares. Good? Good, 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 good. Okay. Find the slope of the line that contains the points 2, 3, and 5, 1. Okay, so we can do the same process here. Put them into our formula. Faster here. So point 1 we're going to label as 2, 3. Point 2 we're going to label as 5, 1. We're going to plug it into our formula, which means that this one here is point number x1, oops, sorry, x2, y2. This one is x1, y1. And if we plug it into our formula, we'll end up with 1 minus 3 divided by 5 minus 2. Right? 1 minus 3, 5 minus 2. I started with this point in the numerator. I continue with this same point in the denominator. Okay? It would be wrong for you to do 1 minus 3 divided by 2 minus 5. Started here, 1 minus 3. I started with this point in the numerator, and then for the denominator, I all of a sudden jump to this one and then do that. Right? So you're going to get the wrong sign if you do that. If you decide to start with this point for the numerator, continue with the same point for the denominator. So this would lead to the wrong answer. And so this reduces to negative 2 over 3. Good? Questions, comments, issues? You could do 1 minus 3 all over, oh sorry, the other way around. You could do 3 minus 1 and then 2 minus 5, right? 3 minus 1 and then 2 minus 5. Questions, 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 questions? No, 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 no. Again, we can put this on a grid, right? Draw the line, there are the 2 points. So in some cases you'll see that they start off by giving you the 2 points like this, ask you to find the slope, ask you to graph them. In some cases they might give you the graph and the line. And so you'll have to either find the points from your grid and use this equation, or you can just count squares. As you can see here, in the horizontal direction, the run, we see a positive 3. We're going to the right, so we see 1, 2, 3 squares to the right. That makes them positive. And then we went down by 2 squares, so that's why it's negative 2. So the rise was negative, it went down, and the run was positive because it went to the right. So 3 and then negative 2. So negative 2 over 3 is our answer. Good? Questions, 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 questions? No? So in general, if we have any kind of a line, then an increasing line has a positive slope. I like to think of it as a little stick person walking on it from left to right the way we read. If that little stick person is going uphill, then it's a positive slope. If that little stick person going from left to right the way we read, left to right, if that little stick person is going downhill, then it's a negative slope. Okay? And so we say that the line is decreasing. Any questions? Find the slope of the line that contains the points negative 9, negative 2, and 12, negative 8. Alright, so can we do this one without all this work? How about, we got to decide which one's which, so we can either have negative 4 minus, well, I'll just write it down this way. We can either have negative 4 minus negative 8 divided by what? Negative 4 minus negative 8 divided by negative 9 minus 12. That's one way to write it all down. I started with the first point. I labeled that one as my point 2. And then the other way to think about this, m equals 2, well, I could start with the second point. That would be negative 8, negative 8 minus negative 4 divided by 12 minus negative 4. Oh, not 9, not 4. Minus negative 9. Good? Questions? Okay, so what happens when we have a subtraction of a negative? Good, so this becomes negative 4 plus 8 all over negative 21. Okay, so then we get an answer of 4 over negative 21, or negative 4 over 21. And hopefully we get the same answer here. This turns into negative 8 plus 4 all over 12 plus 9. And so m equals to negative 4 over 21. Good? Questions, comments, issues? Okay, so we get that. Okay, what if we were given this? Again, very similar to the ladder example from earlier. Looking at this, need to determine which line is steeper. All right, well, we can probably instinctively look at it and decide which line is steeper.
Line 2.
The red one, right? Line 2, L sub 2, the red one, that one looks steeper. But if we wanted to prove it with some slopes, well, this is a case where we can very easily count squares, right? If we look at the rise and the run, on the 3 points that they've really marked, identified for us, 3, 1 is a common point for both of them, right? And if we count squares, we count 1 square to the right, and then we can count up. So for the red line, it would be 1 square, 2, 3, 4 squares going up, 1 square going across, and so we end up with 4 over 1. The slope of the red line is 4, right? What's the slope of the blue line? 2, right? There's 2 squares up, 1 square across, and so we end up with 2 over 1 or just 2. So the bigger the number, positive number that the slope is, the steeper that the line is. All right, find the slope of the line that contains these 2 points, 2, 3 and 6, 3. Okay, so we dive into our formula, and what's going to happen in the numerator? What are we going to get? 0. It's going to be 3 minus 3, 0, right? The denominator is going to be either 6 minus 2 or 2 minus 6, depending on how you did it. Either way, the whole answer is, the slope is 0. Okay, and if we tried to graph these 2 points, they would form a line that is horizontal, right? Because they both have the same height of 3. It looks like this. It's a nice horizontal line. And we saw that the slope is 0. It turns out that the slope of any horizontal line is always 0. 0 is the slope of any horizontal line. What about this one? Find the slope of the line that contains the points 4, 2 and 4, 5. So what's the numerator? Either 5 minus 2 or 2 minus 5, one of those. But what's in the denominator? 0. Okay, and what happens when we have a fraction and the denominator is 0? Undefined, right? Undefined. It's not 0, it's undefined. And what happens when we graph these 2 points? They form a line that is vertical. It's a vertical line because they both have the same x value, so they look like this. Okay, and so that's the general rule. For any vertical line, the slope is undefined, right? Vertical lines have undefined slopes. Okay. All right, so these are general. For any horizontal line, the slope is always 0, it doesn't matter. And for any vertical line, the slope is always undefined. Good? Questions? Okay, what about this guy? These two are parallel lines. What do you suspect is true about their slopes, their steepness? Same steepness, right? That's why they're never going to cross. They always go at the same, they increase at the same rate. So the slopes must be the same. So let's say we have these two in particular. Now we have a nice grid system to them, and we want to find the slope associated with it. So if we want to find the slope of these two, we could find two integer values, right? We don't want to try and guesstimate what that y-intercept is and try and guess what that decimal is. We don't want to do that. We want to look at where the crosshairs are between the vertical and horizontal grid system and have the graph cross right in there. So for instance, it looks like on the blue line, 2, 2 is a nice whole number integer solution that's on that line. And there are others. How about it does cross the x-axis, the blue one, at -4, 0, right? So we can come up with some points. Looks like -1, 1 is also on there. So we can count squares, and so the blue line is going to have, if we're looking at the triangle formed by the point -4, 0 and -1, 1, in the horizontal distance, how many squares are there? 1, 2, 3 squares, and then up by 1 square. So the slope is 1/3. And the same thing happens with the red line. We find a couple of points that are definitely on the grid. How about 2, 0 and -1, -1? And if we count squares in that case, 1, 2, 3, 1, they both have a slope of 1/3. Good? Any questions? No? No? Okay, so parallel lines have the same slope. If lines L1 and L2 are non-vertical lines on the same coordinate system, then the slopes of the lines are equal to M1 and M2. Also, if two distinct lines have equal slopes, then the lines are parallel. Also, if two distinct lines have equal slope, they have the same. Okay. Well, what if they are vertical lines? Two vertical lines, two separate vertical lines are always, they're always parallel, right? So that's kind of a silly thing. You don't have to throw that one in there. Any two vertical lines that are different are going to be parallel. Now, other than that, any other two lines that are not perpendicular, they're going to have slopes. And if those slopes are the same, then we say that they are parallel. Okay, what about perpendicular lines? Two lines are perpendicular if, when they cross, what's special about them? They form a 90-degree angle. And their slopes are going to have a couple of special properties. They're going to be opposite signs. Here's an example. The blue line, a little stick person walking on it, is going to be going uphill. So that would be a positive slope. The red line, a little stick person walking on it, would be going downhill. I know that's a negative slope. And now if we figure out the actual slopes of these two, what's the slope of, say, the blue line? Okay, you got to find a couple of points that are definitely on the blue line. You got to count squares. Blue. Okay. How about the point -1, 0 is definitely on the blue line. What's another point definitely on the blue line? 2, 2. And if we count squares, 1, 2, 3, and then going up, 1, 2. So 2/3. Is that right? Is that the slope of the blue line? Okay. What about the red one? Well, it still has the point 2, 2. What's another point that's definitely on the red line? How about 4, -1? Yes? Okay, so what would be another one that's definitely on the red line? 6 and -4, okay. Alright, so let's count squares. So how many squares is it from 2, 2 down to, what is that? 4, -1. So how many squares down? Okay, so 3, so that'd be negative 3 because it went down. Divided by, and then how many squares across?
2.
Ah. Right? So they're opposite signs, but then also what's going on with the numbers? They're reciprocals, right? So two perpendicular lines have slopes that are negative reciprocals. That's one way to say it. Opposite signs and reciprocal slopes. So those are the same ways to describe it. So here's another pair of triangles on the lines that we can use to find the slopes. So in this case, on the blue one, we went from that little bottom triangle on the left-hand side. So we counted 3 squares this way, 2 squares up, and so we get a slope of 2/3. And on the right, on the red line, we end up getting negative 3/2 as well. Count 2 squares across, 3 squares down in that little case. And so in general, we can write it this way. So there's a couple of ways to write it. If lines L1 and L2 are non-vertical perpendicular lines, then the slope of one line is the opposite of the reciprocal of the slope of the other line. So negative reciprocals, the opposite sign and reciprocals. Also, if the slope of one line is the opposite of the reciprocal of the other line's slope, then the lines are perpendicular. Another way to think about it is the same thing, is to write it this way. The slope of one line multiplied by the slope of the other line is going to give you an answer of -1. That's the way I like to think about it. That looks a little more confusing to me than this. When I multiply them together, what's going to happen to the number 3 and the number 2? Right? I'm going to have 2/3 times -3/2. The 2's cancel, the 3's cancel, everything cancels to give me a 1, except that there's still this minus here, so the answer is -1. So if you take the slopes of two lines that are perpendicular, when we multiply them together, the answer has to be -1. Good? Good?